In section 5, we used long division or synthetic division to factor a piece out of a polynomial. And then from there we had something that we could finish factoring using ways that we had before. But in that section, we were just handed one of the factors or one of the zeros. And without that, where do we start? So if we were looking at this, x cubed plus 5x squared minus 2x minus 24, use synthetic or long division to factor that out. Where do we start? We don't have a zero or a factor, and it would be a pain to just start having to pick numbers out of the air, because there's an infinite amount of numbers to look at. So we want some way to narrow down the list of things that we could try, and then from there we do some guessing and checking. But once we hit one, then it'll divide into something that we can factor. So if you look on your sheet, you see up there the p over q, p and q. That's not too important. But what matters is all of the possible rational zeros. So rational meaning they could be a fraction. So all of the possible zeros are contained in this list that we can make by taking the factors of the constant term, so taking each one of those and dividing it by each of the factors of the leading coefficient. And so those were terms that we talked about back in section 2, factors of the constant term and the leading coefficient. So in this one, the constant term is the minus 24. We're just going to say 24 because we're going to consider the positives and negatives anyway. And the leading coefficient is 1. But it's not the constant term over the leading coefficient, it's the factors of the constant term. So what are all the factors of 24? Well, there's 1, 2, 3, 4, 6, 8, and 12, and I guess, and 24. And the factors of 1, conveniently, are just 1. So we have to take each of those numbers that are on the top, and we put each of them over the numbers on the bottom. So 1 over 1 is 1. And we're going to consider positive and negative 1. 2 over 1 is 2. 3 over 1, so plus or minus 3. 4 over 1, so plus or minus 4. 6 over 1, so plus or minus 6. 8 over 1, 12 over 1, and 24 over 1. So that gives us, what, 1, 2, 3, 4, 5, 6, 7, 8. 8 times 2, because positive and negative. 16 different values that could be zeros to that polynomial. And 16 maybe sounds like a lot, but that's a lot less than just guessing and checking out of the numbers 1 to infinity. So we're going to use this list to guess what the possible zeros are. But for right now, we're just going to be making this list. So let's look at the other example and make the list for that one. So here, again, factors of constant term. So our constant term is 36, and our leading term is 2. So the factors of each of those, we could start with the bottom because that's easier. What are the factors of 2? 1 and 2. What are the factors of 36? There's 1, 2, 3, 4, 6, 9, 3 times 12, 2 times 18, 1 times 36. So we have to take each of those then and put them over each of the numbers on the bottom. So let's go over 1 first. Actually, let's do this. So 1 over 1 is 1. 2 over 1, 3 over 1, 4 over 1, 6 over 1, right? You get that. So we'll just throw all those down here first. So plus or minus 4, plus or minus 6. So there's all of the factors that those are the possible zeros we get if we put them over 1. But now we also have to put them over 2. And a lot of these will repeat. But if we do 1 over 2, well, that's 1/2, and that's a new one. But when we do 2 over 2, well, 2 over 2 is 1, and that's already in our list. So then we have 3 over 2. We would have 4 over 2, but that's 2, and that's already in our list. 6 over 2 is 3, that's already in our list. 9 over 2 is not in our list. 12 over 2, that's 6 and is already in there. 18 over 2 is 9, and 36 over 2 is 18. Okay, so how long is our list this time? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 times 2. So 24. So 24 possible zeros for this one. But again, a lot smaller than looking through infinity. So that's how we make a list of the possible rational zeros.